Surface area of a cuboid is the area of all the faces which make up that cuboid. Now, here we have a cuboid shown. So here's the first face. We've got one face at the front, we've got another face at the back, we've got a third face at the right hand side, fourth face at the left hand side, then we've got face number 5 on top and face number 6 on bottom. And we can better see this if we cut the shape up and lay it out as a net. So here is the net of the cuboid shown. This is the bottom, top, back and front and right and left. So there are 6 faces in total, and what we want to do to work out the surface area of the shape is to calculate the area of all 6 faces. Now, one thing to note, the bottom and the top are exactly alike. They have the same area. Right and left have the same area, and back and front have the same area as well. So if we put in some dimensions, let's say that this is 10 centimetres, 5 centimetres and 8 centimetres. Surface area then, well, let's say, so let's work out the area of the bottom first of all, the area of the base. Area 1, length times breadth. Now, which dimensions do we use to work out the area of the base? Here it is here, 10 times 5. 10 times 5 is 50. Don't forget the units. Area 2, why don't we make area 2 the right hand side? Length times breadth again. I'll not write the formula down. Which dimensions do we use to work out the area of the right hand side? Here it is here. So it's going to be 5 and 8. 5 times 8 is 40 centimetres squared. And area 3, we can let area 3 be the front. So here we are here, it's this face, and the dimensions of this face are 10 by 8. 10 times 8 is 80 centimetres squared. Now, surface area then. Is found by adding all these together, so we've got 50 plus 40 plus 80, but there's something else that we've still got to do. These are just the areas of 3 faces. There are 6 faces. What we have to do is to double the total. So it's 2 times what? 50 and 40 is 90. Plus 80 is 170, so that gives us 340 centimetres squared. Now the other shape that we want to work with is the cube, and we know that the cube has equal sides of equal length. So how does that affect our calculation for working out the surface area? Well, here is the net of the cube shown on the right hand side. And you can see from the diagram that we have 6 equal faces. So all we have to do with the cube is to work out the area of one face and multiply by 6. So let's see then. Let's say this is a cube of side 6 centimetres. So work out the area of one face. Why don't we work out the bottom? So that would be 6 times 6. 6 times 6 is 36. And there are 1, 2, 3, 4, 5, 6 faces which have the same area. So the surface area then is 36 times 6. Now that's 180 plus 36, which is 216 centimetres squared. So here's an example. We want to work out the surface area of this cuboid. We could label some of the faces. Well, we could maybe have, so that would be face 1, the bottom. So area of 1 is length times breadth. So that'll be 10 times 5. That's 50 metres squared. Area 2, well, we could make area 2 the left hand face. So that's length times breadth. Now the right hand face has dimensions 5 by 5, so 5 times 5 is 25 metres squared. And then area 3, well, we could make area 3 the back face, this one here. And it has dimensions, so the back face, well, this here is 10, and this here is 5, so 10 times 5. 50 centimetres squared. And the surface area then is found by adding all these together and then multiplying by 2, because we've got to have the area of all 6 faces. So that's 2 times 125, that's 250 metres squared. Example 2. Now we're told that we have a square-based cuboid with an open top, and we want to work out the total surface area of the shape. The fact that it's square-based is important. It means that this dimension is the same as this dimension here, so this is also 20 millimetres. And I think you can see from the diagram that we don't have a top. So instead of having 6 faces, we have only 5 faces. How does that affect our calculation? Well, let's do some calculating then. So area 1, why don't we let the base be area 1? So that will be length times breadth. And that's 20 times 20, or 20 squared. 400 millimetres squared. Area 2, why don't we let this face be area 2? Now the dimensions of that face are 20 by 12. So 20 times 12, 2 times 12 is 24, so that's 240. Now, lo and behold, when we look at face 3, we find that that is also 20 by 12. Now that shouldn't surprise us, because we are told that the cuboid has a square base. So what I could do then is just to say that equals area 3. Now we have to be careful when working out the total surface area, because remember there are only 5 faces. Let's have a look. So we've got one face on the bottom, which is 400, plus what? Well, this face here is the same area as this face, and the same area as this face, and the same area as this. So 1, 2, 3, 4, these are all the same area. That's because we have a square base. So it's 4 lots of 240. So 400 plus 960 gives us 1360 millimetres squared. Example 3 and final example. This one's a wee bit tricky. What we have here is a composite shape. This shape is made up of two cuboids joined together, and we want to work out the surface area of the shape. So we're going to have to be very careful here because we have a piece cut out. What I'm going to do first of all is to work out all the missing dimensions. So we know that this whole length here is 12, and that this length is 4. So 4 plus this must equal 12. This then is 8 centimetres. I don't think we need anything else, so let's just get started. What I'm going to do is to work out the area of the base. That's going to be 12 times 5. So area of the base is 12 times 5, and that's 60 centimetres squared. Well, there's something that I haven't done yet. This dimension here, which is necessary to work out the area of this face. Now we know that the total height of the shape is 8, and that this is 4 centimetres. So this plus this must give us 8. It means that this then is 4 centimetres high. So I'm going to work out the area of the right hand face. That's this one here. So it's 5 times 4. What about the area of the left hand face? That should be nice and simple. This one in here. So that's going to be 5. That's 5 there. It's the same as this here. That's the depth of the shape. So all of these lines are 5 centimetres long. So 5 times 8. Now, what about the top? This part here. We know that that's 8, and we've just said that that's 5. So that's 8 times 5 as well. So that's the bottom. The bottom is this one here. 5 times 4 is the right hand face. 5 times 8 is the left hand face. 5 times 8 is the top. Now we've still got a number to do. We've got to work out this area here and this area. I think these are both the same. It's 4 times 5, and that's 4 times 5. So area equals 4 times 5, which is 20 centimetres squared. And what about the front? Now that's a problem. This area here. Now, can you see, maybe if I was to draw in, what I'm going to do is to work out the area of the whole face. So area will be 8 times 12, which is 96 centimetres squared, but there's a problem. So there is it's 8 times 12, but there's a piece cut out, which is 4 times 4. That's this part here. Now 4 times 4 is 16. So I'm going to subtract 16 from this, and that gives me 80 centimetres squared. Now, what we have to do is to add all these up together. Let's just check how many we have. So we've got 1, 2, 3, 4, 5, 6, and we've got the front, which is 7, and the back, which is 8. So 1, 2, 3, 4, 5, 6. Now there are 2 missing, and that's because this one and this one are the same. So that's 2 lots of 20. And we also know that the front and the back are the same, so it's 2 lots of 80. So the surface area then is going to be 60 plus 20 plus 40 plus 40 plus 40 plus 160. And that gives us, so 16 plus 4 is 20, 24, 28, 30, 36, that's 360 centimetres squared.